Okay, welcome back everyone. In this video we're going to look at how ray tracing plays out for lenses, and so I'm going to do three examples. This first example is for a convex lens, and we're going to say that this has a focal length of 10 centimeters, and we're going to put our object at 15 centimeters. So that's approximately right here. So that means that this is F, and this is also F. And then I have two centers as well. And remember again that the front center and focus refer to the back curve and vice versa. Okay, so my first ray is going to go in parallel. It's going to start at the object and go in parallel. Now, when you're drawing rays for lenses, you could take the time to draw in every single normal and try to do Snell's law, or you could pretend that the ray goes to the middle of the lens and then does what the rules tell us. And in this case, the rule tells us that a ray that goes in parallel comes out and goes through the focus. Okay? The second ray is one that starts at the tip of the arrow and goes through the focus. And if you don't quite make the lens, that's okay. You just sort of continue with what you think would happen, which is that it would go like so. And I'm actually going to just take this ray right here and try to extend it a little bit so that I get an intersection. That's pretty close. And then I made a bit of a error here. What we want to do is actually mark the center of the lens itself. And so the third principal ray is one that goes through the center of the lens. And you can see that this is working out fairly decently. And so I can then locate my image right here. And this image is inverted and it's larger, which is what we said would happen if 2F was greater than DO is greater than F. Okay, now let's just confirm this using the lens equation. So 1 over F equals 1 over DO plus 1 over DI. So let's calculate DI. So 1 over 10 equals 1 over 15 plus 1 over DI. Common denominator is 30. And 3/30 minus 2/30 is 1/30 is equal to 1 over DI, which means that DI is equal to 30 centimeters, and that totally makes sense. Okay, it looks like it's approximately, well, 1, 2, maybe a little bit more than 3 tick marks away, and each tick mark represents about 10 centimeters. Not perfectly to scale, but you get the idea. And finally, we see that the magnification is negative DI over DO, and in this case it's negative 30 over 15. It's negative 2, which means that it is inverted and it's also enlarged. Okay, so that's the first example. Second example is again a convex lens, but this time we're going to say that the object is inside of the focus. So we'll put it, for example, right here. And as a matter of fact, I think I'm going to say that DO is equal to 5 centimeters and F is still 10 centimeters. Now notice that this is positive 10 and this is also positive 10. Why? Because it's a convex lens. So a convex lens is converging, and so it has a positive focal length. Okay, well, let's do the same thing. A ray that goes in parallel, kind of like so. Remember, once again, we want to imagine that it goes to the middle, okay, is going to bend and go through the focus. Okay, so far so good. And then a ray that goes through the focus, well, we have the same problem as with a mirror. If I just draw that in, if I start at the tip of the arrow and go through the focus, it's going to head off this way to infinity. So instead, what we do is we start at the focus and we go to the lens, and this one is going to be refracted. Sorry if I said reflected earlier. I don't know what's going on there. It will be refracted, so it will go parallel. And now we have the same problem as before. We have two rays that are diverging. Okay, but just for fun, let's do the third. Let's look at a ray that goes through the center. So we have that, we have the center, and we most certainly have problems. Okay, so now I have three refracted rays. Refracted, refracted, refracted. Okay, these rays are diverging. So just like with the mirror, what we need to do is extend the refracted rays backwards. So there's the one that went through the center. Okay, here's the one that came in parallel, and here's the one that left parallel. Okay, and we can see that all three of these come to a virtual focus over here. So this is going to be the location of my image. And this is very similar to a mirror. You get a virtual image, it's right side up, it's enlarged. But let's check the math just to be sure. So 1 over f equals 1 over do plus 1 over di. We can already guess that 1 over 10 equals 1 over 5 plus 1 over di. Well, that's already going to give us negative 1 over 10 is equal to 1 over di, or di is equal to negative 10. So we're a little bit off on the diagram, but you get the idea. And because the magnification is negative di over do, that's negative of negative 10 divided by 5, that's positive 2. So that's right side up. That's how we can tell. Okay, and finally, let's try a diverging or a concave lens. And for this, let's say that we want to put the object at, let's just do 15 centimeters. Okay, now for this, again, it has a focal length of 10 centimeters, but because it's a concave lens, there's a negative sign that goes in front. Okay, so now let's mark our focus. Let's put down our object, and let's ray trace. Okay, now there's something that's slightly different about concave lenses. Okay, now this focus right here corresponds to this side that's right next to it, and this focus right here corresponds to this side. So now when we say that it goes through a focus and comes out parallel, etc., well, now we need to look at the opposite side that we did for convex lenses. For example, our first one is to send in a ray parallel. Okay? Now, the common mistake is then to say, oh, it's going to go and pass through the focus, right? Well, that's not what's going to happen. Okay? And as a matter of fact, what will happen is that this ray will appear to have come from the focus. So this refracted ray will go kind of sort of like this. Okay, and you can actually check this with Snell's law. I'm not going to get into the details here, okay? But you can see that at the first surface that truly what's happening is that I'm drawing in a normal, and that this ray is truly bending towards the normal. It's hard to see. I'll try to draw another diagram in a moment. Okay, so the second ray goes through the focus. Well, at least it tries to. So the second ray starts at the object and it tries to go through that focus right there. But it doesn't make it. It only makes it to the lens. And then once it strikes the lens, it's going to leave going parallel. And once more, we have two rays that are diverging. Okay, but just to seal the deal, we will do the same thing with the center. Okay, and the center one does work similarly. And so the center one will look kind of sort of like this. And once again, we have three diverging refracted rays. So where do they come from? Well, we extend the refracted rays backwards, and this one seemed to come from there, from the focus. This one seemed to come parallel, and look at where they meet, right where that third one is. So here is our image, and this image is reduced in size, it's smaller, and it is upright. It's a virtual image. This is how your glasses work. At least this is how my glasses work. I have concave lenses, and it truly does make a virtual image that's smaller. Okay, now quickly, because this is already long, what about for the math? Well, 1 over f equals 1 over do plus 1 over di. Okay, so negative 1 over 10 equals 1 over 15 plus 1 over di. Okay, so this time common denominator is going to be 30. Now I'm going to do negative 3/30 minus 2/30, so I have negative 5/30 is 1 over di, and di is negative 6 centimeters. Okay, and once again, the focus is supposedly at 10, so looks like it's pretty close. Okay, and the magnification is negative di over do. Okay, so that's negative of negative 6 divided by do, which is 15. Well, we're talking about, if I can do math, about 2/5. And it looks reasonably small compared to the object. Okay, so this kind of wraps up our video on ray tracing with lenses. It was a little long, but we really had to talk about how each of these different setups works. Okay, and finally, we'll do an example problem for ray tracing with lenses.